Hello everybody. My name is Mohammed Islam, as introduced. I'm an engineer at LinkedIn. My colleague Adam Ferris will join with me in this presentation. Our plan is actually to show some experience, some good practice that we learned from our recent migration from Hadoop 1 to Hadoop 2. Especially, in addition, we also did Java 7 to Java 8 migration too. We will cover that in this presentation. Secondly, we will talk about some learnings we learned from multi-resource scheduling, that is CPU plus memory, both together. We want to show some learnings from this testing. Before going to the details of this presentation, I would like to call out what will not be covered in this presentation. Generally, people expect something from here. The number one is we will not talk about how good is Hadoop 2 is. What are the good features? Why Hadoop 2 you should join to Hadoop 2. That is being, I believe, is being presented in multiple presentations previously. So we will not talk about that. We will not talk about any numbers. No performance comparison like Hadoop 2 versus Hadoop 1. This is a common expectation. Also Java 8 versus Java 7. The reason is we don't have that. That's the reason. Number three is actually we also identified that multi-tenancy is a very critical problem for Hadoop. It was there for Hadoop 1, but Hadoop 2 made it more problematic. But we will tangentially touch these topics, and we will not go in depth of these topics either. So before going for this thing, we have to tell some short historical background that we started it last year, and the whole team actually worked, Hadoop operation and Hadoop development team at LinkedIn. We worked to make it to succeed. Some of our ex-members are also, we saw there in the back, they want to see that it's success because they started it at the beginning too. So yeah, thanks to them too. So for these Hadoop 2 migrations, I cannot bring out all of my experience, our experiences. We just selected 3 experiences that we have to discuss. So number one, actually, that is a very common one. If you do or plan, or if you already did, you already experienced this thing. The user comes and they find out their job, they are getting this type of error message. This is common. As you can see from the error message, this is like a cut and paste. That something is, they're expecting interface, they're getting class. So the root cause of this problem is that Hadoop changes the interface to some extent. In Hadoop, it is being, they made sure that runtime, your job will run as it is. You don't need to rewrite your code. Only thing you need to do is recompile your application with Hadoop 2 jars. The reason of this failure is some of your artifacts is being compiled against Hadoop 1. So these are very common things. And so actually, for resolution purpose, as I already mentioned, you need to recompile. You need to get the Hadoop 2 jars and recompile your application with that. However, a lot of cases we experienced that users are complaining, oh man, I do not have any Java job. I do not have anything to compile. I'm running a pig script, something like that. Why I am getting this error? So the reason is they are not using it, but they are transitively using it. That means they have a third-party jar they include. This is the common error that they see. So in this case, we ask them to go and grab the Hadoop 2 compliant pig jar or Avro jar, whatever jar is complaining about. In a very rare cases, what happens that people find out like actually the third-party jar they are using is not behind the schedule of supporting Hadoop 2. In this rare case, you might need to recompile it and put it in your local artifactory so that your other users can use it easily. the second issue. It is the jar version conflict. This is a very common issue we see. So what happens is actually Hadoop system is provided their jar, and Hadoop user is using their jar, providing their jar, and both version does not meet the same version. There are two different versions, and you see this problem is coming along, and the error messages come in different form, depending on which jar conflict happens. And these 5 jars are the common we experience from our all these Jiras and other things we find out. Now the question comes out that why this problem is happening. This is a very well-known problem. Any JVM-based system has this class loader problem and this jar version conflict. So we actually considered multiple options. One of these things is a Hadoop-based option that is currently available, where Hadoop provided the class loader. 2 types of class loader: there is system-level class loader and user-level class loader. And the application, the user application cannot create any problem for the system, and vice versa too. There is another option actually we were considering, that is shading. That some of the product actually use the shading technology to do it, and that was not that easy for Hadoop to do it for different reasons. The another things also we actually evaluated was the well-shaded containers. This is also good, and I think a lot of other big Hadoop, Java-based systems is using this technology. So what we ask our user, we take some technique, we put some technique here. We enforce our users that you need to upgrade to newer version. The reason is that the user never change. Their application is running, they will never change to newer version. There some of the people are using 10 years old jar. It's hard to get any jar support for those architectures. So force them to upgrade. So that is the technique. This is a non-technical approach. But technically, if indeed some jars come and we find out that they need the older version of jar, what compared to what our Hadoop needed, in that case we ask them to use this class loader approach and pass this parameter with their jar. So issue number 3. This was a compatibility issue, and it is not a API compatibility. It is like actually behavioral compatibility. Just take this example of list status. So somebody did this list status previously in their code, and they are passing some path that path does not exist. But previously it was returning null, and they wrote the code if return value is null, do this. Now in the newer Hadoop 2, list files will throw an exception. So their code will not work. So now they need to go and change their code. They can do 2 things. One, adopt this exception, or accept this exception, handle this exception correctly, or change their code so that they call file exists before they call list status. Yeah. So let's come to our different things actually, like JDK8. So this is the interesting thing. Like when we are come to JDK8, everybody asks this question. Why JDK8? LinkedIn is actually very early adopters and doing it. This question is coming along, man, we are struggling our user to use JDK6, and we are planning for JDK7, and you guys are for no reason, for some reason, jump into JDK8. What is the reason? So we have some answer, but this answer comes from different direction. Number one, we find it like actually JDK8 has very cool features like lambda and other things. A lot of people are doing it. JDK8 is, they are claiming that JDK8 is a performant. They give good performance for different cases. And their garbage collector is very good. We saw this, how bad experience with garbage collector with Java, we know that. So one user, we found it in our LinkedIn, these people are always in the cutting edge. They always go, for various reasons, they go and use the latest version of everything. So we are anticipating that very soon they will come with a JDK8 compliant job or job to run on Hadoop. So we are preparing us for those users. And above all is actually it is a company mandate. I should call it out very fast. The rest of the thing just to comment. That is the reason actually we are doing it. So let's come back to our JDK8 experience. Okay, we were using it and let's see that actually what we learned. Most of the problems is coming from memory issue. And we divided these problems into two categories. One is the heap memory problem, where Java heap, out of heap memory are a common problem, and JDK is killing that. The killer is JDK. So the question will come actually why Java 7 does not have this problem, but Java 8 is creating this issue. So we investigated it and now we went to the JDK 8 documentation and tried to understand it. We find out as follows. Number one, JDK 8 reorganized their memory management or re-architect their memory management. What they did primarily, actually they moved some of this non-heap memory to heap memory. I don't know the reason. They re-architected it that way. So we can assume, so they put some overhead on the extra overhead on heap. So they already claimed that there will be some heap level overhead will be there. But how much? The question will come that everybody is talking about that how much our job need more heap for JDK8. There is no mathematical thing, no scientific things. We cannot say okay 10%, 5% increase your memory, it will work fine. So we take some defensive approach and we start asking our users who experience this problem to increase by half a gig, for example, and they are happy and it's working fine. We don't know it's a very lot of memory we are asking. So, but the main problem is, in this case, I should call out that this problem is not for every job. So maybe 2% or 3% jobs is experiencing this problem. So we generally came to an agreement that maybe these jobs were playing on the boundary of the previous memory allocations. Now probably due to the JDK8, they crossed the boundary and been killed. So that's probably our assessment at this point. So we asked the people to increase those two parameters as common to increase the heap memory. And alternatively, we did some other approach that also worked to some extent. That is, by looking into all these failure cases, we find out the reducer is facing this problem, and their shuffle is facing the problem. So we asked them to reduce this shuffle percentile. But I know that there is a high possibility the performance might get some impacted. If the default value for this shuffle input percent was 0.7, we asked them to reduce to 0.5. Our problem is solved, but maybe the performance is not getting worse. So those are the actually tricks we use to unblock our user. Let's come to the second memory issue. This is the virtual memory. Now the killer is Hadoop itself. It's not JDK problem. Hadoop is enforcing these features. Again, if you use JDK7, it's fine. If you use JDK8, the problem comes up. So we need to identify actually why JDK8 is happening. Again, we went to their documentations and tried to find out. Then they again changed this thing. All non-heap memory, they changed those things. They added new things. They put the new boundary. One of the things called max meta space. They put their maximum size could be infinite. So we are not sure actually all these, there is at least 3 parameters are there. Those are the things actually playing indirectly in some extent to the virtual memory things. So for this region, we are looking for multiple solutions. There are 3 types of solution. One is what you can do, you can disable the virtual memory check in the Hadoop level. But it is not a good practice at all. Because if you stop it, some of your rogue job can take as much virtual memory as it wants, and it can pull down your whole system. So this is the one approach a lot of people are actually suggesting. The second approach is relatively better than the first approach. That is currently Hadoop enforces or calculated the virtual memory by using the physical memory. For example, you ask for 1 gig physical memory. The virtual memory Hadoop is calculating by multiplying 2.1 by default. So actually they will always look for 2.1 gig of virtual memory. If you go beyond that, Hadoop will kill. But there is a knob is there that you can increase this value from 2.1 to some other higher value, 4.15, something like that. At least you have some upper limit is there, so you can do that. As we find out the root cause of the problem, why JDK8 is so wide of getting the virtual memory, try to control it. That is the actually root cause. We need to find out. We do not have a very clear answer yet. Actually, we are actually trying to update those things in our Jira in the open source also. Like this, one of the things actually we find it out one case. This is one of the parameters, that's the max meta space size. This is a JVM parameter. So we can change these parameters and try to reduce it. We saw that actually virtual memory problem gone. But still we do not have a very clear answer of this problem. But we know some workaround to do it. So far we find it out JDK8 experience is okay. There is no big blocker at this point. Things are working fine. However, we need to plan for rainy day. What is that rainy day? JDK8 is relatively new. In one day, one of you, our user might come and tell, oh man, my job is failing only for JDK8. For JDK7, it is working fine. So what is the answer? And we find out that it's taking longer time because JDK8 does not have a lot of experiences people do that. Nowadays people are coming with this experience. So identifying the problem, resolution, resolve this problem, we need to have some backup plan, how to unblock this user. So this is like operational help, because you know that if one user can create so many noise, right? So to do it, there is some workaround. Somebody might call it a dirty workaround. So what we did actually, that you can override the JDK8 requirement. You can pass the Java home through your job. You can ask, okay, I want to use JDK7. Don't use, for my job, don't use JDK8. And his job should work as it is. So this is like a workaround. The reason is actually we do not, for the longer term, we do not suggest this thing. This is an operational nightmare. Because if you guys, less number of variables is easy to control. In one system, if you see JDK6, JDK7, JDK8 is running with a lot of Hadoop level variables, it's very hard to manage. But on this transition phase, I find it out, okay, we'll selectively allow this thing. After that, we will stop supporting this thing. This slide is nothing, I will not talk much on that. This is one to show we actually not only enforce making sure Hadoop 2 is working, we made sure that peak, high, all these tools are working with Hadoop 2. In some of the cases, we have to put some patches on the open source and make it work. Having said that, I want to hand over to my colleague.
Good evening. So initially after setting up a Hadoop cluster, Hadoop 2 cluster, one of the first issues we had was getting data onto it. We were using DistCP to copy data from Hadoop 1 to the new Hadoop 2 cluster, and we ran into the CRC checksum errors. If you're not familiar with this, there's several JIRAs documented in it. But essentially, the CRC checksums changed between Hadoop 1 and Hadoop 2. In Hadoop 1, they used a CRC32 checksum. Hadoop 2 uses a CRC32C checksum. The main difference being is, since 2008 with the Nehalem processors, Intel's been adding a CRC32 checksum code inside the CPU. So when the developers decided to release Hadoop 2, they went with the newer, faster checksum. So what ends up happening is when you run DistCP, you start seeing checksum mismatch errors. The way to get around this, and there's a lot of bad info on the internet, which is why we have the slide up, but they'll say disable the CRC32 checksums with DistCP. It's bad advice. You can get around it by setting the CRC checksum type, as you see here. The other problem we ran into with DistCP was out-of-memory errors. In the source, they set the default map and reduced memory sizes to 1 gig. So if you're DistCPing a lot of files, it would blow up with ON messages. This is kind of tricky to track down for us because we're looking around on the file system and there's no DistCP default XML to be found. Well, it turns out this is part of the source, and when the source gets built, it gets bundled into the jar. And because it's part of the jar, if you're an end user trying to override these settings with -d values, it gets ignored, and so you're stuck with the 1 gig size. The fix to this was to remove those values from the source code, recompile the jar, and submit it with the cluster. So, one of the great praises of Hadoop 2 is there's no longer an artificial separation between map and reduced slots. Everything's just a slot. And thusly, it's providing better utilization. Of course, with this, there's also the idea of an application master. And we found out that the application master ends up adding additional overhead. Our ETL team, when they copy files, they have lots of small map-reduce jobs, maybe 1-2 mappers per job, because they're copying on a file-by-file basis. At LinkedIn, our default application master size is 4 gigs. Our task slot size is 2 gigs. So for a single map-reduce job, that's 6 gigs of memory, which by itself doesn't sound that bad, but when you're ETL and you've got lots of jobs running, the capacity scheduler kicks in, the limits that we have configured kick in, and start throttling the jobs, and the ETL team's coming to us and asking why are the workflows running slower overall. So one of the ways we got around this is there's this concept of Uber mode. It's a job configuration setting that can be enabled by the user. What this does is any task get ran inside the application master container. So if you have a single a job with a single task, the task will get run inside the container. So instead of running 6 gigs of memory, you're only using 4. By using Uber mode, our ETL team was actually able to get back to their normal schedule. So it was really helpful. This slide's more of a policy slide than technical. Earlier we mentioned when people migrate to Hadoop 2, they may have old jars with them. What we've been able to do is use Hadoop 2 as a carrot. We ask our users, if you want to migrate to the new grid, or the new cluster, you should replace the old jars with these new versions. Because I don't know if it's because they feel like they're getting rewarded, but it seems to work out a lot better. When before we would ask them to upgrade these jars with Hadoop 1, and we get pushback of, we don't have time, or it's running fine, leave it alone. So take the time to clean up any old accumulated corrupt. When you migrate to Hadoop 2, it's a good time to do it. Multi-resource scheduling. Really what we're talking about here is multi-tenancy, but because there's so many aspects to that, we're just talking about the scheduling. And why this is important. Even with Hadoop 1, there's a need for limiting resources. You might have a job come in and take all the disk or CPU. And this is still true in Hadoop 2. With the different frameworks like MapReduce, Spark, Tez, everybody's going to be competing for similar resources. Current resource limits are based on memory usage. So first one in wins. If I want to use a bunch of CPU, I'm going to get it because I'm the first one there and everybody else starves on CPU. With Hadoop 2, they recently introduced CPU scheduling as well. It's not widely used. There's lots of bugs to discover. We're not running it at LinkedIn because we need to investigate it further, but it does look promising. It implements the dominant resource fairness algorithm, which basically looks at both CPU and memory the way it's been implemented in Yarn. It looks at both CPU and memory, and whichever resource is used more of, it weights against that. So it works a little better in that it takes into account other resources. Unfortunately, this doesn't implement enforcement. It's just scheduling. So what the Hadoop developers have done is they're relying on the Linux kernel secret subsystem for enforcement. It's a kernel feature that isolates and limits resource usage. But you have to remember it is provided by the kernel. It's not a Hadoop feature. So if I have a Microsoft Windows cluster or Solaris cluster, this isn't going to help me. Our tests were done on a 120 node cluster. and we were testing both memory and CPU scheduling, and it seemed to work as advertised. Just for a test yarn app, we were using the bin stress Linux utility. It's just a command line tool. It throws the CPU or memory into typed loops and basically burns a bunch of electrons. It's kind of fun. But using stress, we were able to confirm that for the most part it seems to be working. Disk I/O throttling and network throttling is not part of the yarn framework, but we went ahead and tested it anyway, and what we found is that disk reads are throttled, but disk writes are not. And this has to do with the Linux kernel not implementing this feature into the block I/O subsystem. More methodology and results will be published on this in the future with a blog. Here's a list of JIRAs that were opened with patches contributed by LinkedIn engineers during the migration, just to show that we are contributing back to the community. So, to close, basically what we found is Hadoop 2 with JDK8 is working well. Hadoop 2 is mature and seems fairly stable. Migration from Hadoop 1 to Hadoop 2 is not effortless, but it's doable. And what we found is multi-tenancy is better, but it still needs some work with Hadoop 2. I'd like to say thank you and, for sticking it out, and have a good evening.
Question.
Yes, sorry.
So you mentioned about 6 gig memory even for your small jobs. Can that not be configured that you use lesser memory just for the small jobs, even if your default configuration is for 6
We could
gig?
use less, but that assumes the user is smart enough to set that setting, to tune that setting. So by default, that's where those numbers came from.
So what are the two problems that you want to see in the multi-tenancy setup? Or is it you want multi-tenancy still?
But it's an unsolved problem. It's a lot better, is what I mean. There's still more work to be done on it, though. It's just resource scheduling, yes. Yeah. Isolation, yeah.
So would you sort of categorize that as more beyond
This is more.
rather than
It's a. Yeah.
This is making open source.
no, it's 2.3
But this is I just read up on
Please use the mic, then we can catch it.
There is a Microsoft. We are aware of that.
You're making a result for changing the environment variables, and I can use Java 7. Now, what about if you compile Java 8? That particular file is
Then it will not. I forgot to mention. Exactly.
they change the in those cases.
But now they do this combining with
Have you guys explored any like task preemption, like if two? No, not. That's something which in a multi-tenant environment that's very much needed. Thank you.